Bell X-1 was the first plane to break the sound barrier, but its radical design pushed pilots and engineers to the edge. The rocket engine's unpredictable thrust and the aircraft's tiny, cramped cockpit made every flight a gamble. High-speed instability and violent control responses led to multiple near-fatal incidents. As speeds increased, the X-1's design limitations became clear, and the program was eventually restricted to prevent further risk to test pilots and ground crews.
North American X-15 pushed the boundaries of speed and altitude, but the risks were immense. The aircraft's rocket engine produced temperatures that could melt metal, and the thin skin was prone to failure. Pilots endured extreme G-forces and the constant threat of loss of control at the edge of space. Several catastrophic accidents and the psychological toll on test crews led to strict operational limits, and the X-15 was ultimately retired as too dangerous for continued flight. Northrop YB-49 was a flying wing bomber that promised revolutionary performance, but its instability was legendary. The lack of a tail made the aircraft difficult to control, especially in turbulence or during landing. Multiple crashes and fatal accidents exposed the design's aerodynamic flaws. Political pressure and the inability to guarantee crew safety led to the program's cancellation, and the YB-49 was banned from further development in favor of more conventional bombers. Bell X-2 was built to explore the edge of hypersonic flight, but its technical challenges quickly became life-threatening. The aircraft's thin wings and exotic fuel made it dangerously unstable at high speeds. Pilots faced severe control problems, and the X-2's tendency to enter uncontrollable spins led to fatal crashes. The combination of aerodynamic unpredictability and extreme pilot workload forced the Air Force to ground the program, banning further flights to prevent more losses. F-84H. Thunderscreech was the loudest aircraft ever built, with a supersonic propeller that created shockwaves on the ground. The extreme noise caused nausea and disorientation in ground crews, while pilots suffered from severe vibration and control issues. The aircraft's engine was so temperamental that it often failed to start or caught fire. The Air Force banned further testing after repeated safety incidents, citing unacceptable risks to both air and ground personnel. Convair B-58 Hustler was the first supersonic bomber, but its high-speed design brought a host of problems. The aircraft's thin delta wings made it difficult to land, and the ejection seats were unreliable at low altitudes. The B-58's complex systems required constant maintenance, and its nuclear mission profile exposed crews to extreme psychological stress. Mounting accident rates and the shift to less risky bombers led to its early retirement and removal from nuclear alert status. Lockheed F-104 Starfighter was a record-setter for speed and altitude, but its razor-thin wings and high landing speeds made it unforgiving. The aircraft's tendency to enter flat spins and its short range led to hundreds of crashes, earning it the nickname Widowmaker. Political scandals over export deals and mounting pilot fatalities forced several air forces to ground or restrict the F-104, and many countries banned it from frontline service. Yakovlev Yak-38 was the Soviet Navy's first VTOL fighter, but its technical limitations made it hazardous. The lift jets overheated quickly, and the aircraft was prone to engine failures during vertical takeoff and landing. Pilots faced high accident rates and little chance of survival in emergencies. The Yak-38's poor reliability and operational risks led to its early withdrawal and a ban on further development of similar design. Soviet rocket interceptors, like the MiG-19 SM and Sukhoi T-43, were built for rapid climbs to intercept bombers, but their rocket engines posed lethal dangers. Toxic propellants, limited endurance, and explosive ejection systems made every mission a gamble. Ground crews risked exposure to hazardous chemicals, and pilots had little margin for error. The combination of technical hazards and operational impracticality led to these aircraft being banned from regular service.
Convair B-36 Peacemaker was the largest bomber ever built.
But its mixed piston and jet engines created constant mechanical headaches. The aircraft's massive size made it difficult to maintain, and the crew endured long missions in cramped, noisy conditions. The B-36's nuclear role exposed crews to radiation risks, and its vulnerability to new air defenses led to its rapid retirement. Strategic doctrine shifted, and the B-36 was banned from further nuclear alert duty. Boeing B-52, in its low-level nuclear strike configuration, pushed the airframe to its limits. Flying at treetop height to avoid radar, crews faced extreme turbulence and the risk of structural failure. The stress of constant alert status and the psychological burden of nuclear war plans wore down aircrews. After several near misses and accidents, the Air Force banned low-level nuclear strike profiles, shifting to safer, higher-altitude tactics. Tupolev Tu-95 nuclear patrol variants were designed for continuous airborne alert, but the combination of long missions and radiation exposure proved unsustainable. Crews spent days at a time in noisy, vibrating cabins with little protection from the nuclear weapons they carried. The risk of accidental detonation or crash landing with a live warhead led to the banning of continuous nuclear patrols, and the Tu-95's mission was redefined. Tupolev Tu-22M Backfire was a high-speed bomber with a reputation for instability and maintenance nightmares. The swing-wing design created aerodynamic challenges, and the engines were prone to flameouts at high altitude. Crews faced long missions over hostile territory, with little chance of rescue if something went wrong. Political pressure and arms control treaties eventually restricted the Backfire's deployment and led to bans on certain mission profiles. Rockwell B-1A was designed for supersonic penetration, but its advanced systems were plagued by technical failures. The variable geometry wings and complex avionics made maintenance a constant struggle. Political debates over cost and arms control led to the program's cancellation, and the B-1A was banned from production. Only later, with major redesigns, did the B-1B enter service under strict treaty limits. North American ex-B-70 Valkyrie was the fastest bomber ever built, but its titanium structure and complex systems made it a maintenance nightmare. The aircraft's high-speed flight envelope created dangerous shockwaves, and a mid-air collision during testing exposed its vulnerabilities. The ex-B-70's nuclear mission was rendered obsolete by missile technology, and arms control treaties banned further development. The program ended with only 2 prototypes ever flying. Nuclear-powered bomber prototypes, like the Convair NB-36H, were banned due to the extreme risks of airborne reactors. The aircraft carried a working nuclear reactor for testing, exposing crews to radiation and creating the risk of radioactive contamination in a crash. Environmental and political concerns, along with the technical challenges of shielding and maintenance, led to the cancellation of all nuclear-powered bomber projects. Lockheed U-2 was a high-altitude reconnaissance aircraft that became a political flashpoint. Its overflights of hostile territory led to international incidents, and the risk of being shot down was ever present. The U-2's fragile airframe and narrow flight envelope made it difficult to fly, and several were lost to accidents and enemy action. Political pressure and arms control agreements eventually restricted its use and led to bans on certain missions. Lockheed A-12 was the CIA's secret predecessor to the SR-71, but its extreme speed and altitude pushed technology to the breaking point. The aircraft's titanium skin was difficult to maintain, and the engines were prone to unstarts at high Mach numbers. The secrecy surrounding the program created operational and psychological strain for crews. Political concerns and the risk of escalation led to the A-12's early retirement and a ban on further flights. Lockheed SR-71 Blackbird was the world's fastest jet, but its operational risks were immense. The aircraft's engines required special fuel and could flame out at high speeds, while the airframe expanded several inches in flight due to heat. Pilots wore full pressure suits, and any emergency meant ejecting at Mach 3. Political pressure and the cost of operations led to the SR-71's retirement, and arms control agreements banned further reconnaissance over certain regions. RQ-170 Sentinel was a stealth drone designed for covert surveillance, but its capture by hostile forces exposed the risks of secret technology. The aircraft's advanced systems were vulnerable to electronic warfare and hacking. Political fallout from lost drones led to restrictions on their use in sensitive areas. The need to protect classified technology resulted in bans on certain missions and tighter operational controls. Messerschmitt Me-262 was the world's first operational jet fighter, but its engines were notoriously unreliable and prone to flameouts. The high landing speed and poor acceleration made it dangerous for inexperienced pilots. After the war, the Allies banned further production and use of the Me-262, fearing its advanced technology could destabilize post-war air power balances. Heinkel HE-162 was rushed into service as a last-ditch German jet, but its wooden construction and poor quality control made it hazardous. The aircraft's engine was mounted above the fuselage, creating balance issues and a high risk of fire. Many crashed due to structural failures or pilot error. The Allies banned the HE-162 after the war, and surviving examples were quickly scrapped. Mitsubishi J-8M Shusui was Japan's attempt at a rocket-powered interceptor, but its volatile fuel and short endurance made it a death trap. The aircraft's engine could explode during startup, and pilots had only minutes of powered flight before gliding back to base. High accident rates and the risk of catastrophic failure led to the banning of further development after the war. Low-altitude sonic boom bombers were banned after tests showed that shock waves shattered windows and damaged buildings for miles. The environmental and public health impact of routine supersonic flight led to international agreements restricting such missions. The combination of technical, legal, and political pressure forced air forces to abandon low-level supersonic bombing runs. High-altitude ozone aircraft concepts were shelved after studies revealed that their exhaust could deplete the ozone layer. Environmental concerns and international treaties banned the development of aircraft that threatened atmospheric stability. The risk of long-term global harm outweighed any strategic advantage, and these projects were quietly cancelled. Rocket-powered interceptor programs, like the American F-91 Thunderceptor, were banned due to the extreme risks of rocket fuel and limited operational value. The aircraft's engines were difficult to control, and the risk of explosion was ever present. The rapid pace of jet development made rocket interceptors obsolete, and treaties restricted further work on such dangerous concepts. Extreme nuclear strike aircraft concepts, including plans for orbital bombers and doomsday planes, were banned by international law and strategic doctrine. The risk of accidental launch, uncontrollable escalation, and global catastrophe led to treaties prohibiting their development. The combination of technical, political, and ethical concerns ensured these aircraft never left the drawing board.